So we'll chat about that later. So it's 4:01. So let's get started here. I think, we got 100 people. That's awesome. So I'm going to share my screen now. If you guys could just let me know that you can see it in the chat, that would be fantastic. Okay, where'd the chat go? There's the chat. 601. Yeah. You can see it. Okay, great. All right. So here's kind of how this is going to go. I'm going to teach, and then I'll try and stop, maybe every 15 minutes or so and look through the chat questions, but I can't watch both the chat and the, and my screen and see what I'm doing there. So, just bear with me. I'll try to get to all questions, at the end if I can. So just write the questions in the chat that you have. Or save them for the end if you want. And then if there's something wrong, like you can't hear me or my screen goes away, say it in the chat, and I'll periodically kind of check the chat if I can. I think there's also a raise hand feature. So that would be helpful if anything goes wrong, if one of you guys raised your hands, because I think it kind of alerts me of that. Not sure. Anyways, all right. So I asked, I'm going to do a live lesson. What topics do you guys want to hear? We got a lot of, people saying cross country. So we also got a lot of people saying E6B, and then some people saying performance charts. So from my experience doing this and teaching this stuff, I know that, E6B calculations and performance chart calculations are sort of the biggest questions around cross country planning. So that's what we're going to focus on here today. And then if you could let me know, can you still see the screen now that I switched to this PowerPoint? Yes, okay, cool. All right, so this PowerPoint is our cross-country planning guide that's in our online ground school. So we're gonna use this kind of as a guide, but there's a lot of stuff in here that I'm not going to cover. I'm just gonna kind of breeze through because we don't have the time. And I wanna focus our time on examples of the actual calculations and performance charts. So in today's lesson, we're gonna do the performance chart, and then, sorry, just making sure we're still recording. We're going to do performance chart type calculations. And then in next week's live lesson, we'll do the E6Bs. So the calculations involve E6Bs. So between this week and next week, you should be able to know how to do all the calculations needed for cross country. All right, so let's get started. Okay, so let me, I'm just going to leave it like this. I'm afraid that if I go full screen, something will mess up with the recording or something like that. So I'm just going to leave it like this as long as you guys can see that. Okay. All right. So the first thing I like to do is just draw a straight line. So I'm going to, like I said, I'm going to kind of breeze through the first kind of plotting, picking checkpoints, all that stuff. So I just draw a straight line from where I'm taking off and where I'm landing. Then I determine my checkpoints. I look at things like, terrain, airspace, altitudes, alternate airports for safe landing if there's an emergency, stuff like that. And then I find some good, checkpoints, visual checkpoints, like this lake near French Valley here, stuff like that. So that's how I determine my checkpoints. And then I start building my, NavLog. So that's kind of the NavLog example we're going to go with. Then you get out your plotter tool on your sectional chart, or if you're using ForeFlight or something like that, you can just measure directly on there and it'll give you the magnetic courses. But if you're measuring on the sectional chart, which if you're a student pilot, this is your first time, I recommend using, learning that way, because you're going to get questions like that, either on the written or your Checkride, and the examiner wants to know that you can do it the old school way. So we measure on the plotter. When we measure this course, that's going to give us our true course when we're measuring straight off our sectional or terminal area chart. So we do that for each leg of flight. We put in our true course. And again, I'm flying through this. I know if you have questions on anything specific on one of these steps, just remember it, write it down, put it in the chat, and I'll try and get to it at the end. Then we got to convert to magnetic course. So we find what the variation is using these isogonic lines of the chart. This one says 12 east. So we subtract 12 to our magnetic course to get our or sorry, to our true course to get our magnetic course. So here we have, the true course, and then we have the variations here, and then the magnetic course here. Okay. And then next thing we do is we want to measure our distances. So we just want to make sure that we're using the right scale on our plotter tool. So as you can see, there's a bunch of different scales. There's a terminal area scale. You can hardly see it, but that's this one on the inside of it. Then you got, nautical miles here. You got a sectional, and then the whack. And then so you just want to make sure if you're looking for nautical miles, which we are on a sectional chart, then you want to use this top scale up here. So just make sure you have the right scale. And then you can, boom, do the same thing for each leg, but now we're measuring distances. And then we put those distances into our NavLog. And then we also want to kind of do an accumulation of the distances, right? So this one is always the total distance you've flown. So when we're at Palma Valley, it's 17 nautical miles from KRNM to Palma Valley private, but we've flown a total of 33 from our takeoff at KAC. All right. Next thing, we want to figure out what our altitude is. So we're going to look at things like airspace and terrain, and maybe the ability to glide out of bad terrain to if we lose an engine, stuff like that. Those are things to consider. So this is just kind of me going over the path, right, and picking some altitudes. Right here, originally I say at Lake Jennings that we want to climb and stay below 3,800. That's because there's a class Bravo. If you just got clearance or flight following, you could go right through that and climb straight to 8,500. I talk about this in more detail here. That's kind of your choice, right? Some student pilots, they're not, you have to have an endorsement. Student pilots have to have an endorsement to fly in class Bravo solo. So that's kind of why I say you might not have that. So you might need to stay out of class Bravo, but it would be obviously easier to just get that class Bravo clearance and flight following. But that's why I said that there. All right. Then what I like to do, and this is a huge trick that I learned. Let me just check the chat here, make sure no questions or issues. Okay, cool. All right. So I like to, right now that we have the total distance, so this is our total distance number for our whole flight, is do an estimation of the fuel that we're going to need. We'll get an exact estimation later, exact calculation later, but this is just an estimation. And the reason I do this now is because you want to know now, before we do all this work calculating all our performance, we want to know if we need a fuel stop or not. Okay, so if our fuel tanks hold 48 usable gallons, we want to know how much we're going to need to make this right now. If it's over, that 48 gallons, including reserves and all that, then we know we're going to have to stop somewhere to get fuel. That means adding in checkpoints somewhere in here, right? And, descents and climb back up. And so it's going to change a bunch of things. It's going to change these numbers and these numbers. So you're going to have to redo it, like all of it. So to avoid doing that, I like to just estimate the fuel. And to do that, you can just assume a ground speed. And then you can just use time equals total distance divided by ground speed. So here I estimated ground speed for the aircraft that I'm assuming we're flying, like a trainer aircraft, of 95 knots. The slower the ground speed, the more conservative your estimation. So we say, okay, it's going to take us about 1.2 hours. And then for my aircraft, I say, okay, it's about an average of 10 gallons per hour. That could be more, depending on your aircraft, could be 12, 15, whatever. Again, you can use a conservative value. So we just do 10 gallons per hour times 1.2 hours, 12 gallons. And then we add in other things. So that's just our flight. We want to add, like a gallon for engine startup, taxi run up, the approach and descent, add 5 gallons to that, about a half an hour. This is what I do. Not everyone does this or the amount here, but it's good to, if you get to an airport and then you have to stay in the pattern for a bunch and you didn't plan for that, it's good to plan for at least, I think, a half hour of flying in the pattern before you land. And then finally, reserves, right? You have the day reserves of a half hour after you reach your destination in cruise flight, or you have night of 45 minutes. So we're assuming we're flying in the day, so that's another 5 gallons. So you add that all up to the 12 we came up with, say, okay, we need 23 gallons. So if this aircraft requires, can carry 48 usable gallons, then we're good. We know now, before we do all this work, that we don't need a fuel stop. All right, so now then we would gather winds and temperatures. These screenshots are a little old. The aviationweather.gov has been updated, and it's a lot kind of cleaner. So these are kind of old, but the same data exists. Just how you find it on the website is a little different. So we get winds aloft data, right? So we're flying in the San Diego region here, and we look at our altitude. We may have to interpolate a little bit, and we get our winds and temps. And then we fill that in for our cruise flight, right? So that was for 8,500. We don't know our altitudes quite yet that we'll be at before that, because we'll be climbing, right? So we may have to do some interpolation, say, okay, at Palma Valley, we'll be about 6,500, and at KRNM, will be about, 3,000. I show some ways to do this in detail in this guide. We're not going to cover them here. But if you have questions, you can, ask me later or send us an email on how I like to do it. Anyways, so then we're going to start to do our performance calculation. We want to see, okay, how long does it take us to climb? Because we need to know that to know, as well as the time it'll take to climb and the fuel it'll take to climb. So we start to get into using our performance charts. So the first thing is we're going to need our information. So our takeoff elevation, we're going to say is 3,088 feet, and that's at KC, Gillespie Field, here east of San Diego. And then a cruise altitude of 8,500 feet. And then we need these to be in pressure altitudes. So we'll assume that this is our pressure altitude for this one. And then we also need the temperatures for our performance. So let's assume these temperatures, these are a little hotter. I kind of did some funky temperatures on this one, some non-standard temperatures. You'll see why later when we get into the examples, but obviously, it's not always 11 degrees Celsius up here, 9,000 feet. That's pretty hot for up there, but I wanted to do something different, and we'll get to that in a later bit. So first thing we want to do is get everything in pressure altitude. So our elevation is not in a pressure altitude. So to do that, you can use, I think, figure 7 in the Airman Testing Supplement has a pressure altitude conversion factor, or you can use this equation where it's your elevation plus 1,000 times the standard altimeter setting minus the actual expected altimeter setting. So here, when we do inside the parentheses first, we get 0.12, multiply that by 1,000. That gives us 120. We add that to 388, and we get 508. So that's our pressure altitude. Now that we have our pressure altitudes, we have everything we need. We have the pressure altitudes at our takeoff and cruise altitude, and then we have our temperature at takeoff and cruise altitudes. So now we whip out our fuel time and distance to climb chart. Now I'm going to do these in an example here. So I'm going to switch the screen. All right. Let me know that everybody can see this still. I just want to make sure. Yes. Okay, cool. All right. Now this is for a Cherokee Warrior. This is what the chart looks like. And on the FAA written exam, they might have you do a chart like this, or they might have you do a chart like this, which is just like a table, which is a Cessna. So, which I believe Cessna's use. So we're going to do an example using both of them, right? So you might see both on the written exam or in real life. Okay. So what we have to do is we have to do this twice. So I'm going to try my best to draw some lines here. Let's see here. All right. Why can't I? All right, hang with me here. There we go. All right. So let's do a line. Let's do a red line. Okay. So we want to do this for our takeoff elevation and temperature. So we're going to follow. You can see these dashed lines. These are examples. And up here, it kind of tells you some information on how to use it too. First thing we want to do is start over here on this bottom axis down here, which is the outside air temperature in Celsius. So we want to find 17 degrees Celsius. That's going to be about right here. And then we want to draw a line straight up using these grid lines until we reach 8,500 feet on these kind of curvy lines. So we see this one is, labeled 8,000 here. This one kind of right here. And then we have 9,000 here. So we want to stop at 8,000, or sorry, I take it back. I'm jumping ahead. That's our cruise altitude. We're still over here. We're on our takeoff altitude, which is only 508 feet. So that's going to be actually way down here. So we have our 1,000-foot line. Oops. We have our 1,000-foot line right here. And then then the 0 line would basically be down here. So 500 is going to be in between those. So we simply find 17 degrees and we draw a line up to what we think would be about 500. So maybe right there. Then we take that intersection of the 508 foot line, right? Curved line, and then our 17 degrees Celsius, and we draw a straight line over. Now, this is really hard to see right here because these lines are all bunched up, right? But what we need to do now is we need to read where this red line intersects the fuel curve up here, this fuel curve here, and then where it intersects this time curve and where it intersects the distance curve. All right, so obviously they're all bunched up like right here, and then we have these little scales. It looks like every 5 blocks is equal to 10, so that means every block is equal to 2. So we can kind of just do our best. When you have short altitudes, it's pretty difficult, and there's some air involved. So we just do our best to judge that. So this outside line is distance, so that should be the most. I'm going to say that's about at the 2 line. So distance is 2. Then time is our next line. That's this line right here. And we're going to say that, it should be a little bit inside the distance curve. So we'll say that's about 1.5. And then the fuel is even more, that's almost hugging the line here. So we're going to call fuel 0.5, basically almost 0, but we know we'll use some fuel. Okay. All right. So this is for our takeoff up here. Now we want to do this same thing for cruise. Let me do a different color. So now we're going to do cruise. We're going to get a distance, a time, and a fuel. All right. So now let me erase these here. We'll use blue, and we're going to do this again, but for the cruise values. So now we do the cruise temperature, which is 11 degrees, and we go up to the cruise pressure altitude of 8,500. Starting at 11 degrees, which is about right here, we're going to go up to about right between the 8,000 and 9,000 lines, which is about right here. From there, we do a straight line over. And I know that's not a straight line. I don't know how to get this tool to draw a straight line. I feel like I have the line tool picked, but I don't know why it's curvy. Anyways, it's good enough for our purposes here. Next, we just simply draw a straight line down so we can read off each line, each intersection, right? So distance, same thing we did before. So distance is going to be about 38. Time going to be about maybe 27. And then fuel going to be, you just got to make sure you're not crossing grid lines, which is kind of, can be frustrating. And it looks like fuel is about like 5. All right, so let's write these down. So fuel is 5. And then time we said was 27. And as you can see, it's easy to make mistakes if you rush, and you draw your line and you draw it crooked, or because these are so close together. So just do your best and always err on the side of being conservative when you're actually planning this stuff for an actual flight. All right, so now we have values for at 508 feet and values for at 8,500 feet. We want to know the fuel time and distance it takes to climb from 508 feet to 8,500 feet. So we want the difference between these two sets of values. So we want to subtract 38 by 2 to get 36. Then we want to subtract 27 by 1.5 to get 25.5. And then for fuel, we want to subtract 5 by 0.5 to get 4.5. All right. So the units are these are gallons, this is minutes, and this is nautical miles. So now we know it's going to take 36 nautical miles, 25.5 minutes, and 4.5 gallons to climb from 508 feet, pressure altitude 508 feet, to a pressure altitude of 8,500 feet at these temperatures. Okay. So before I open up to questions, I'm going to do now the same thing. I'll show you briefly how to do this on the Cessna chart. It's the same process. We do it once for the pressure, the takeoff, and then once for the cruise. It's in a different format, right? It's in this table. So first of all, we want to find 508 feet in this column here. Obviously, we just have sea level and 1,000. That's akin to these curved lines, right? Okay, so we want to kind of interpolate between these. We can just, because 500 is directly in between them, that'll be easy. Now, our temperature, and this is where this kind of chart lacks a little bit, right? We only can choose from like one temperature. So if our temperature isn't really standard, like it lists here, these are like the standard temperatures, what do we do? Now, some aircraft, POHs or approved flight manuals will have like, for each 10 degrees above standard, add blah, 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 blah. And it'll have like a temperature correction factor. That's why these are more accurate, these charts, because we can actually choose our exact temperature. Anyways, we are stuck with what we have here. So we're just not going to really worry about temperature. It's a little bit warmer, so our performance will be a little bit worse. We just have to keep that in mind, thinking of density altitude. So we're just going to go here, kind of in the middle here. One thing that's nice is it gives us a rate of climb in feet per minute. And then, so time here, we're going to do like 0.5 for time. Fuel is going to be like between 0 and 0.3. So that'll be, fuel will be 0.15 if we divide that in half. And then distance is going to be 1 because we're interpolating between 0 and 2. All right, now we're going to do the cruise values. So we're between 8,000 and 9,000. So we're right here in the middle again, between two curves. Temperature says should be, if it was standard, should be -2. Obviously, we're, 13 degrees hotter than that. So we really should be applying a correction factor to that because, again, our performance is going to be worse. But for this case right here, we don't have that. So we're not going to do anything. We're just going to keep it simple for this example. All right, so then we come over here, interpolate between 15 and 17 for our time. That's going to be 16. All right, then for fuel, we're going to interpolate between 2.7 and 3.2. So that's going to be about 3. And then we'll interpolate between 19 and 22. and that's going to be about 20.5. And then we would do the same thing. We find the difference between these two. So time, we would have 16 minus 0.5, the difference between the two times, 15.5. And again, this is minutes. And then we would do fuel. And so that's the difference between 3 and 0.15. So it's like, what, 2.85. We round that up to 2.9. We always want to be conservative with fuel. And that's gallons. And then distance, we have 20.5 and 1. So we subtract 20.5 by 1, and we get 19.5. And that's nautical miles. All right, so that is how you would do it on a Cessna. All right, any questions here on climb performance, either using the table or the chart? Scott says, can you make your screen a full screen shot? I worry that I've had this happen before. Can you guys still all see that? Yes, okay. All right. Hopefully it still records. I've had it happen before where I was doing like a PowerPoint presentation and it wasn't recording anything. Okay, Victor says, do we take wind into consideration for takeoff and climb? What about weight? Does it affect the takeoff and climb? So for climb, we usually don't consider anything other than, as you can see here, we have a weight listed. It's an assumed weight, which is, usually near kind of what they would expect you to take off with, like almost full tanks. But climb performance charts generally do not take into account weight or wind. They simply keep it to temperature and pressure altitude. Wind would affect your ground speed and time and stuff like that. So we do eventually take into effect wind. And then for takeoff, we do take into effect the weight and the wind. So for our takeoff, ground roll distance or our landing ground roll distance, we will use weight and wind. And I hope to get that today to show you guys that performance chart. But for climb performance charts, these aircraft manufacturers usually don't consider that. For our numbers, should we not look at notes and adjust as per notes? For the Cessna chart, I mean. Should we not look at notes and adjust? Oh, these notes up here. Yeah. Oh yeah, there are notes. Oh, thank you. Yeah, that's what I was talking about. I didn't realize they were up here. Yeah. So I didn't do that. I will show you how to do that in another example. But yeah, so we would increase our time, fuel, and distance 10% for each 10 degrees above standard, right? So we're about 12, what would we say, 12 or 13 degrees above standard. So I would increase everything by about 12 or 13%. So I would increase this, so you just multiply that by 1.13 to increase it by 13%. Same with that. Yeah, great call. I didn't see these up here. I thought I had a picture without that. So thank you. All right, let me continue on. Good questions. If you have any more, please ask them and I'll get to them when I can. All right, let's see here. Back to this here. Okay. All right, so we've done that. We've done this stuff here. All right, now what I'm going through here is I'm saying now that we know our total distance to climb, it would be nice to have a checkpoint at that distance so that we know when we reach that checkpoint, that should be about, when we're done climbing. Plus, it makes things easier in that we can have everything before that checkpoint in our climb phase of flight and everything after that checkpoint in a, cruise phase of flight. So that's what I like to do. I'm not going to show us how to do it here, but basically I just found another checkpoint that would match our end of climb. So I changed that here. And then we can figure out what at each checkpoint, what altitude we'll be at if we were to just climb all the way to that. So that's what I'm doing here. Again, I'm not going to cover that detail. You can also take your climb rate, right, from your AFM POH, if you have that, and say, okay, well, I know it's 5 nautical miles and my aircraft climb rate is, 250 feet per nautical mile or something like that. And you can use that to figure out the altitudes here that you'll be at these checkpoints. So a couple ways to do it. But again, like I said, we're not going to get into the weeds on that. I want to make sure. Okay, now total distance to descend, just like climb, we have charts on fuel time and distance to descend charts. Now, not usually the FAA doesn't ask about this. Not all aircraft have charts for descent. Not all charts have, descent charts. But if you did, it would be the same exact process. So we would do it once, right, for cruise, but this time we're starting at cruise. So cruise out, so 11 and, 8,500. So that's about right there. And then line over, right? And then you get your fuel time and distance, and then you do it again at your, and I like to do the pattern pressure, the pattern altitude of where I'm landing, right? I kind of call that my, bottom of my descent. So I do, for this example, we did about 4,000 feet and 25 degrees Celsius. So we would do this to here, to 4,000 feet, and then do that over. And then we mark down the fuel time distance, and then we subtract the two, find the differences, and then we would get our fuel time and distance values for our descent. So same thing. I know a lot of people for fuel on descent, they just like to calculate it the same way they do on cruise because it's more conservative. You burn a little bit more on cruise. And that's actually how I like to do it as well, rather than these charts, because these charts kind of have some error, and I'd rather be, again, conservative. But I'm not going to go show you the whole thing here, but it's the same type of chart for descent if you are flying an aircraft that uses that performance chart. All right, let's go back here. Kind of continuing on our plan here. All right, so now we know the distance to descend. We can also, what I'm doing here is I'm also choosing a checkpoint to start my descent at. So just like I did at climb, I like to have checkpoints at the end of my climb, right at the end of my climb, and a checkpoint right where I should start my descent, so that I know. It just makes things easier, dividing your flight up like that. Okay, so that's kind of what I'm doing here, and then finding the altitudes at each checkpoint. And again, you could use like a descent rate to do that as well. All right, now I'm getting, so this has changed. Again, the aviationweather.gov, how you get this, you would just use the graphical area forecast tool, or the GFA. I used to use this chart, which I really liked. It was like a time chart of like all this stuff. I don't think they have this anymore, unfortunately, but you can do the same. You can get the same data using the GFA tool. So this is old. But we're basically getting our winds, our temperatures, and wind speed. We're getting that at our, like, at ground level. And then we would also use winds aloft again, which I didn't show, to get like, 5,000 feet. Anything above like 3,000 feet, we can use winds aloft. And then anything below 3,000 feet, we can use like surface information. And what I like to do is I like to, interpolate a little bit to, sorry, can you guys all still hear me? I just want to make sure. I just had, okay, cutting in and out. Yeah, I just had a note that my internet was unstable, so sorry. Hopefully that gets better. Okay. Yeah, so let's say, for example, right, for this area, there was winds aloft at 3,000 feet, and then, so we would use surface analysis, right? Surface temperatures and surface wind data for the surface, obviously. And then we would use, like we would interpolate between like 3,000 and 6,000 winds aloft for KRNM checkpoint. And then here we would interpolate between the 3,000 winds aloft and the surface for, our winds and wind speed and temperatures. Okay, seems good now. Okay, thanks, guys. All right, let's see here. Continue on. So we gather all our wind and temperature data. Let's see here. All right, so what I'm explaining here is that, and this is how I like to do it. And again, this is why I divide it into, a climb phase of flight and a cruise phase of flight. So when we climb, if anybody that's had a flight lesson yet, you take off and you usually climb at, either the best angle or the best rate of climb, right? So you usually target an indicated airspeed, right? So for a Cherokee Warrior, the best rate of climb is 79 knots. So we know we're targeting an indicated airspeed. So that's what we start with, right? So that's what I put here. I say, okay, we're going to fly 70 knots. Now in cruise, the way I do it is I usually just set an RPM, and whatever airspeed I get, right? I'm usually not saying, I want to fly 120 indicated or something like that. I usually just set an RPM, and what I get. So we usually start with an RPM when we're in cruise flight. Same thing with descent. Here, right? If we want to descend, we'll back off on the RPM a little bit and we'll just, descend. We don't really target usually an airspeed until we get back into like the pattern for landing. Then we want to, get into our approach airspeeds and all that. So that's what I put here for what we start with. And that's going to dictate how we come up with our true airspeed. So that's the next thing we want to get to, is we want to get to our true airspeed. And then once we have our true airspeed, we can apply winds to get our ground speed, and then our wind correction angle and our magnetic heading. So our next goal is a true airspeed. That'll get us to a ground speed. And then once we have ground speed, we can use distance and ground speed to get a time to each checkpoint. Once we have time to each checkpoint, we can get fuel to each checkpoint. So that's the destination that we're going. So the next step is true airspeed. So we can do it two different ways. When we know the indicated airspeed that we're flying at, like in climb, right? We want to target 79 knots of indicated airspeed. That's when we simply use our E6B. Now, I'm not going to show you this today. We're going to show you this next week because we're going to do all the E6Bs kind of in one thing. But you would simply use the airspeed correction here to go from an indicated airspeed to a true airspeed. Okay, or indicated airspeed in this example, we assume is the same as calibrated airspeed, but technically you go from a calibrated airspeed to a true airspeed. But we'll talk about this next week. So this is in climb. This is how we come up with our true airspeed in climb. We'd use our E6B. Okay, now for cruise, we don't know an indicated airspeed, so we're starting with RPM. So how do we do it in cruise? Well, we can use performance charts from our AFM or POH. So the first thing we can do is we can convert this RPM, this targeted RPM, to an engine power setting, okay? And this engine power setting depends on the condition of the conditions that we're in, the temperature and the altitude. So this is, Cherokee Warrior PA 28161 engine performance chart. And I'm going to show you guys an example of how you would use that. We're going to use that to get a power setting in terms of percentage. And then we're going to turn around and use that percentage on our best power cruise performance chart to get a true airspeed. So let's show you guys how to do that. So here's the engine performance chart right here. Let me let's do the line. We'll do red. All right, so we have our cruise checkpoints over here. We have a target RPM of 2,500, temperature of 11 degrees Celsius, and altitude of 8,500 feet. We would do the same process for our descent checkpoint, our single descent checkpoint, where we lowered our RPM to 2,300. And then for our temperature and altitude, what I would do is I would just take the middle. Obviously, the temperature and the altitude are changing because we're descending, we're changing altitudes. So I like to just take kind of the middle temperature and the middle altitude. But we're just going to do this chart once for the sake of time. We're just going to do it for the cruise checkpoints, but you would do it again for every time you change RPM. All right, so just like the climb performance chart, we find down here on the temperature scale, we find 11 degrees, and then we're going to draw a line up until we meet 8,500 feet. So let's do that. About 11 here. 8,500 is about here. I think that's a straight line, straight as I'm going to get. All right, and then from there, we draw a horizontal line. And then now we want to find which one of these kind of lines intersects with our RPM. So the RPM is down here. So our RPM for cruise is 2,500. So we're going to draw a straight line up. And our intersection is right here. So now we just kind of eyeball this and say, okay, what diagonal line would this intersection be on between 55 here and 65 here? Oops. Okay, so you just kind of eyeball it, you know, say, okay, you know, make sure that the line is parallel. Like, okay, this is like almost directly in between, maybe a little bit closer to 65. So let's call that 61% for our power setting for our cruise. Now that we have that, we can come use our cruise performance chart. Okay, our cruise performance chart needs that, you know, percentage of power. So that's why we had to do that. All right, so now we have our target power setting of 61%. We have same temperature, same altitude. And then we would do this again for descent. So if we did it for descent at 2,300, you know, in our kind of middle temperature and middle altitude during our descent, we'd get a target power setting of about 51%. So we would do this again. Here, we're just going to do the cruise again for the sake of time. So again, we find 11 degrees here. We go up to 8,500. That looks decently straight to me. And then we draw a horizontal line over. And then now we see there's a 55, 65, and 75% lines. We want to draw where our 61% line would be. So it's going to be about in the middle of 55 and 65%, maybe a little bit closer to the 65% line, maybe something like that. Make sure it's parallel with the other lines. And then now at this intersection, we draw a straight line down to our true airspeed right there, which is about 111 knots. Okay, now there is a note here that if you have wheel fairings, if wheel fairings are not installed, so this assumes you have wheel fairings. Wheel fairings are these like shrouds that go over the wheels that make them more aerodynamic, so you get better performance. So if they're not installed, subtract 7 knots. So let's assume that we don't have wheel fairings, because a lot of aircrafts at flight training schools do not. So let's subtract 7 knots to our 111. That gives us 104 knots true airspeed. All right, so let me just flip over here. So we put in 104 knots, and then we do the same for our descent, about 91 knots, and boom, we have our true airspeeds. Now we can use the wind data and our true airspeeds to get our ground speed and our wind correction angle, and then finally our magnetic headings. So that we would use the wind side of the E6B, so we'll do that next week. But do you guys have any questions before I get, so that's what we do here. Real quick before I take your questions, that's what I do here in the next steps. So now that we have our true airspeeds, we're using that and the wind at each checkpoint to find, with our courses, to find our wind correction angle, magnetic headings, and ground speed. So then once we have ground speed, we can find time using time equals distance over ground speed. And then once we have time, we can just use a fuel consumption rate here that we find For a Cherokee Warrior, the fuel consumption rate is listed on the best power cruise performance for cruise. Might be listed somewhere else for your aircraft, but it lists fuel consumption rates for per engine power setting. Since we know our engine power setting, we can interpolate, remember it was 61% in cruise. So we can interpolate about an 8.4 gallons per hour fuel consumption rate. We can use that. We just take that fuel consumption rate, multiply that by the time in hours, and then we get the fuel that we're using. Okay. So that's how you do it all. That's how you come up with fuel and everything like that. Again, the E6B parts we will cover next week, but there is one more thing that we're going to get to, and that's takeoff and landing distances, because those use performance charts. We haven't really talked about those yet, but before I do that, I want to see if you guys have any questions. All right, so Luke says, I apologize if this was explained. I'm at work, so I missed a few minutes. Where did we get the target cruise power of 61% from? Is there a chart to find that? Yes. So depends on your aircraft, but for a Cherokee Warrior, we have a engine performance chart. Okay, it just for any certain temperature and pressure altitude and RPM, it'll give you a power setting in terms of percentage. So that's what we did, because we have the tachometer, right, when we're flying, and in cruise flight, usually how most people teach it and how I learned it is you just want to set, you don't want to go full throttle. You want to back it off a little bit from full throttle. We're not really too worried about saving fuel or anything like that. Maybe you lean the mixture at that altitude, but you usually target an RPM. So we're taking that targeted RPM of 2,500 at our temperature and pressure altitude to get a percentage, a rated power percentage, and then we use that in our best power cruise performance chart. Yep, no problem. Any other questions? You can see that. So the recording of this is going to be put in the online ground school bonus course. It's the bonus downloads and video vault course. So that's where all my past live lessons are to be watched to your heart's desires. Okay, I'm going to continue on here. All right, so, and we'll take questions after. I just want to make sure we get to the takeoff and landing distance, because they're a little bit different in terms of performance chart stuff. All right, so, oh wait, one more thing actually before we move on. A cruise power chart may also look like this. I believe, I always fly Cherokee Warriors, but I believe a Cessna chart looks like this, and this is what you might see also on the FAA written exam. So very similar. So sorry, I kind of jumped ahead. I forgot about this, but I do want to show you this. It has 3 sections here for temperature, right? It has a standard day temperature, as a -20 degree standard day, as a +20 degree standard day. So that's the first one. You find out which section you are. Okay, so standard temperature is 15 degrees at sea level, and that's Celsius. At 8,500 feet, and at a lapse rate of 2 degrees per 1,000 feet, so 2 degrees per 1,000 feet, that means we drop 2 degrees for every 1,000 feet. So by the time we're at 8,500, we've dropped 8.5 times 2 degrees. So we've dropped, what is that, 17 degrees. So standard temperature, and we saw this before, at 8,500 feet should be -2 degrees at 8,500. But we are at 11 degrees. So we're 13 degrees over standard temperature. So we kind of are in between these two charts. So if you want to be real accurate, you could, get a value in this chart, then get a value in this chart, and then interpolate between, standard day and +20 at +13. For this example, we're just going to assume we're ISA +20. That's worse performance, so it's a little bit more conservative anyway, so that's okay. So the next thing we want to do is pressure altitude here. We're going to find 8,500 feet. Again, a little bit more interpolating because we only have 8,000 and 10,000, so we're going to be somewhere in between. So then we come over here, follow this line here. So we're on this line right here, and we simply just find our true airspeed in knots right here, 164. It's 166 for the at 10,000, so 8,500. If we interpolate it, it'd be 164 or 165. That's fine. You can also get, nice thing about these charts, you can get your fuel consumption rate right there to calculate fuel when we get to that. And then you also get your engine RPM. All right. So sorry about that. I kind of jumped ahead, but that is how you use a chart like that. And then now, let me see if there's any questions on that. Yeah, video will be in the bonus section of the part-time pilot account. Okay, so takeoff and landing distance. The first thing we need to do is figure out which chart to use, because a lot of aircraft POHs have multiple charts. So they usually talk about something called a takeoff ground roll, and then a takeoff distance to clear 50 foot obstacle. So what does that look like? Well, if we start our takeoff right here, so we're sitting on the runway and ATC says, go ahead and take off. Okay. So when we just start to inch forward right here. All right. So that's the start of both of these distances. Now, right when we lift off, right when our wheels lift off the pavement, that's our takeoff ground roll distance. Okay. So, and then you also have 0 flaps and full flaps. Okay. So you'll have, to choose. If you're using full flaps, then you want to use the full flap takeoff ground roll or takeoff distance to clear 50 foot obstacle. So if you have an obstacle like near the runway, which you'd find in the chart supplement or something, or if you should know your runway, if there's a crane or a tree or some terrain, then you want to use takeoff distance to clear 50 foot obstacle, because you want to make sure that you can clear a 50 foot obstacle. And that's this distance. This is the distance from where you start to move until where you are 50 feet above the ground, higher than 50 feet above the ground. It's that distance. So sometimes they call that the takeoff performance. So this is also, that distance to clear 50 foot obstacle is also sometimes called the takeoff performance. And then you also have, like a 25, 2 notches, 25-degree flap takeoff options as well. So whether you're using flaps or you're not for your takeoff, and whether you have an obstacle or you don't, determines which one we want to use. All right. And then for landing distance, we have similar things, except no variations for flaps. They just assume you have full flaps on landing. So we have a landing distance, which is shown here. So it's right when your wheels touch the ground to when you come to a complete stop. That's your landing distance. And then the landing distance over a 50 foot obstacle is from the distance of the 50 foot obstacle all the way to the complete stop. So it's just the reverse of the takeoff ones. And then to make sure to look for obstacles, you don't want to look here, on the chart supplement. You can maybe find it in the airport map or the remarks, or up here in the runways. You just want to look, like here for runway 18, you see it says hill. So and if there's any ambiguity, if this is a new airport, you can always call them up and ask them, right? And again, it's always safest to just do the distance to clear 50 foot obstacle takeoff distance, right? To always be conservative. All right. So one thing we need to know for our takeoff and landing performance is our winds. Now, I'm not going to go into too much detail, but we basically need to know how much headwind we have. It's also good to know how much crosswind we're going to have and where it's coming from, so we can input crosswind controls. But in terms of performance, we just want to know how much of a headwind component we have. So that's what I'm doing here. I'm using trig functions to come up with the headwind for takeoff and our headwind for landing. And then, so I'm just gathering all that information so that we can use these charts. So let's go ahead and do an example using these charts. All right. So we have, we're going to assume 2,100 pounds for our takeoff weight. Okay. So that includes our fuel and all that stuff. And then we have forecast winds of from 210 at 3 knots. Our pressure altitude is 508 feet. Our runway direction, we're taking off runway 27, so that's 270. And then 17 degrees Celsius. And our headwind component, which we calculated using, you can use the chart. There's many ways to calculate crosswinds, and we have a video on this on our YouTube. You can go check it out, or in our lessons. Again, I don't want to spend time here, but I like to use the trig functions. It's just easy to me because I'm kind of a math guy. So we calculated 1.5 knots as our headwind component. So that's not the total component. Obviously, the total component is 3 degrees, but at that 60-degree angle from 210 to our takeoff angle of 270, that gives us a headwind of 1.5 knots. All right, so how do we use this chart? Well, it's very similar until we get to the end here. All right, so we want to find our temperature of 17 degrees and draw a line up to our pressure altitude of 508, which is going to be about right there, because this is the sea level line, and then the one that says pressure altitude is essentially like, or wait, sorry, no, it would be up to that line there. This line that says pressure altitude is actually the 1,000-foot line. So we draw it to there. And now the difference about these charts, it has these reference lines. Okay, it has a reference line here, has a reference line here. So what we want to do is every time we find an intersection and then we draw a line over, we stop at each reference line. We basically stop and then we restart on this new section of the chart. So this next section is the weight, as you can see down here, on the x-axis. So now we want to follow these curves to our weight, our takeoff weight. So our takeoff weight is 2,100 pounds. So let's just draw a line up from 2,100 pounds so we know where to stop. And then, now this is going to be tough because it's a curved line, but you essentially just want to, when you're doing this in real life, you want to take your pencil and just follow the closest line to you. It curves a little bit. I'm drawing a straight line, but you get the gist. Just kind of follow the same trend of that line until you meet your weight line. Okay. Then from that intersection, what do? Again, we draw a horizontal line all the way over to the next reference line where we stop again for the next section. This section is wind and knots. And then you can see it goes 0, 5, 10, 15. So this is, depending on what wind we have, it's going to affect our final takeoff ground roll, right? So a tailwind, you can see, has these curves that go up, okay? And they would increase our takeoff ground roll. Our headwind has these lines going down. Now, we always want to plan to land in a headwind. So I don't know who would be using this chart, planning to land in a tailwind, but it's there if you need it, right? If you, let's say you have to land at the airport and there's a tailwind, might come in handy to do this calculation and see what effect that tailwind has on your takeoff roll and if you'll have enough, room on the runway. So we start here, and then we basically follow these parallel to these headwind lines, or sorry, follow down on these headwind lines, so parallel to these headwind lines, until we get to our headwind component, which is 1.5. So it's not very much. So our headwind component is going to be about right here. So that's our line for our headwind component. So we simply just follow the line parallel down. It's not going to go very far until we reach that line. And then from that intersection, we draw a straight line over. And that's where we read off our final takeoff ground roll. So 500 here, 1,000 here. I think there's 1, 2, 3, 4, 5. There's 10 notches. So each notch is 50 feet. So we're 2 notches down. So we're about 900 feet for our takeoff. 0 flaps. Oops, 900 feet for our 0 flaps takeoff ground roll. So we assumed we didn't have an obstacle and we're taking off without flaps. And we get 900 feet. All right. Any questions? Yep. You guys are saying thank you for the love. No problem. I get it that you got to go. Victor says the flight log you are filling up, do you have it fillable somewhere online, or do you just print it yourself and fill it up on paper? So this flight log here is just for presentation on this PowerPoint. But we do have some in the online ground school or our Checkride prep bonus course. Victor, I don't know if you're in our online ground school or not, but if you want to send me an email, team@parttimepilot.com. Okay, yeah, so check your bonus course. They should be an Excel file and a PDF file. The Excel file, I like to do things all on my computer and just enter them into Excel file and have Excel do the math for me on things. So there is an Excel file in there, but there's also a PDF if you want to print that off. And the Excel file, you can also kind of adjust the size of the columns to your liking and hide columns and then print it off from there. So yeah, just check your bonus downloads course. Cade, that's a great question. I made a mistake. Yeah, I did it wrong. You're right. I should have went to in between 1,000 and sea level for the 508 feet. Good catch. So to finish it up, I know some of you guys might have to drop off, but we would do the same thing for landing ground roll. The only difference here is we want to kind of estimate what our landing weight would be. So we can just say, all right, well, we estimated, how much fuel we would use, not including reserve. And then we know fuel is 6 pounds per gallon. So if we use 14 gallons, that's about 85 pounds. So we say, okay, by the time we land, we've lost 85 pounds, as long as no passengers were thrown out of the window or whatever, right? So that's all we lost. So we can estimate our landing weight, and then we just do the same thing for landing. I'm not gonna do it here, but it's the same process, right? It's I'll just do it real quick. So we got pressure altitude about 4,025 degrees Celsius. So do like 4,000, then boom over the reference line, about 2,000 pounds here. Not drawing straight lines, I know. So we'd go down to that, and you come over to the reference line again. This time our headwind for landing, because our winds are 195 at 9 knots, and we're landing on 1.8, so it's almost a direct headwind. So we have a headwind of 8.7 knots, and headwind goes down. So we want to go down to about 8.7. So 8.7 is about, somewhere in there. So we'd go there and then draw that over. And that looks about like 520 feet to land. Again, assuming no obstacle. All right. Any other questions you guys have? I plan to take, like 10 to 15 minutes of questions at the end. And yeah, good catch, you guys. Yeah, Pamela, no problem. I self-taught my stuff on this as well. So any more live lessons? I do plan on doing a mock Checkride oral with somebody and filming it and having that available. Funny part about that is I did do it with somebody. I got a volunteer and we did it and it went great. He was super prepared and crushed his Checkride, and it was great material. And I messed up the recording on the Zoom, and so we didn't even record it. But he was prepared. So yeah, I will eventually. I try to do these live lessons, every few months or so on topics that are of interest to people. So that might be the next one I do, Melissa. But we do have the Checkride prep course, which has a really, really lot of good material already in it. So I recommend that in the meantime. 𝐁𝐿𝐥𝐵, not sure I'm pronouncing that, but you're welcome. No problem. Thank you for coming. Scott, do you have a step-by-step on the cross country? So we have a lot of stuff. I think this is it's either in our Checkride prep course or online ground school bonus course. This is the Checkride prep guide, literally every single thing. So that's what I've just been following. And then we have like a checklist, so you remember all the steps you got to take. I think we left that for, especially now because the FAA Written is focusing less on calculation stuff. I think that's in the Checkride prep course bonus downloads. Latoya, I hear a lot of people say that the oral could be difficult. Yeah, it could be. I mean, it's the eye of the beholder, I guess. I don't know if that's the right way to say it, but the oral exam, let me put it this way. The more you struggle, the harder it's going to get. So it's in your best interest to just make a really good first impression on your examiner. And one of the first couple, and this is what we talked about in the Checkride prep course. The first thing you're going to do is show that you're qualified to take the Checkride. So that's you're gonna show you have all the minimum hours required, all the endorsements in your logbook. So if your logbook is all messy and stuff, you're gonna annoy the examiner right away. So you want to have that all neat and tidy and pointed out. Then the next part is you want to prove that your aircraft is airworthy and ready, and legal to fly that day. So then you'll go through the maintenance logs and make sure it's through all the inspections and it's airworthy and all that stuff. So that's the other thing. If you have that all tidy and ready to go and you've prepared, a couple days ahead of time, and mark, I in our Checkride prep course, I say, earmark where the latest inspections are and where they're signed off by the mechanic. So you can just flip right to that. Again, that'll really impress. And then after that, the third thing is they're going to show you, have you explain the cross-country plan for the day. So that's where this comes in handy, this cross-country planning. As long as you have an answer for why you did something, and the source of that is always the POH AFM from the aircraft or the FAA, then you're good to go. And then finally, they're going to throw in situational based questions on the subjects that you miss on the FAA Written. So those 4, 5 things, if you focus on those, you can make your Checkride oral go rather smoothly. So it's all about, just like anything else in life, right? Preparation, practice makes perfect. So I'm getting ready for my Checkride soon. I have been following along and this helps. No problem, Angelo. Does the DPE let you know in advance if you should plan everything on a sectional and NavLog, or is ForeFlight okay for the use of planning? That's a good question. I think so. You can usually communicate with the DPE. They're going to give you kind of what they want. They're going to say, hey, plan a mock cross-country flight to this, and we're going to fly the first few checkpoints of that, or whatever. That's what my DPE did, and that's what others I've heard of commonly do, right? They have you plan an entire cross-country flight, and then you start flying it, and basically that's the start of your lesson. You start flying that, and they show they watch you navigate and stuff, and then maybe they'll say there's an emergency, a mock emergency, or maybe they'll say you lost, they'll get you lost or something, have you divert, something like that, after you've shown you can fly the first couple checkpoints. So I would just, when they tell you, they're going to give you the requirements of what, they might say, plan it to this airport with this weather data. You might just go ahead and ask them, like, hey, can I do this all on my iPad on ForeFlight, or do you want paper NavLogs as well? If I were doing it, I would bring paper NavLogs just in case, because what my Checkride examiner did, and I know that they're supposed to be getting away from this, but the first thing they did on my cross-country flight is he said that my iPad battery caught on fire. What do I do? And so I had to tell him that I had to throw it out the window because I didn't have a fire bag. And then that meant he held my iPad for the rest of the flight and I couldn't use the iPad. So be wary for that. That could happen. They're not supposed to do that. They're supposed to, if you have it, but you never know. All right. That was kind of long-winded. Why do charts always use a 50-foot obstacle as the example? What if there is a taller obstacle? Do we ever need to calculate how to clear a taller obstacle? Wow, that's a good question. I think there's an FAA regulation. There's like around airports, around a certain radius around an airport, you can only have up to 50-foot obstacles. So I think that's why, Tracy. I'm not 100% sure. If you're taking off from like a private airport or something that doesn't comply with that, you would have to kind of do your own climb performance calculations, right? So you'd want to make sure be able to get off the runway in time, have enough runway to lift off. And then after that, it becomes a climb performance calculation to see if you could get to an altitude high enough before that obstacle. All right, Joe P. I was told we can use ForeFlight for the NavLog. However, he said to be able to explain everything on it and how you would get those numbers. If you can answer questions and explain it, then he doesn't mind ForeFlight. Yeah. So basically, if it shows a true course, explain how you went from magnetic to true. Or yeah. So yeah, that's good. Yeah. And the best way to explain or show that how is to just do it by hand. I don't know. I'm kind of old school like that. If I'm the type of pilot where even if it's a 0.01% chance, I want to prepare for it. If I can do that, to 10 different things and be prepared, that gives me if it's a 0.1% chance, now I've just gotten a 1% chance of my successful flight better, I will take it. So in the event that 0.1% chance that my iPad fails, I'll have that stuff with me in paper form. So that's why I like to do it. But as long as you can explain it, you're right. It should be okay. So if he fails your iPad, you can use a GPS. If you have a GPS in your aircraft, you could. But if you don't have a GPS, usually people use iPad ForeFlight and GPS if they don't have a GPS in their aircraft. So if you didn't have a GPS in your aircraft, you would have to navigate, pilotage and dead reckoning and using BORs. I've been told no ForeFlight, no direct to. Yeah, it changes depending on the DP. That's why I'm saying like it's best and safest to just know how to do it without. Like, don't take the easy way out. It might come in handy for you one day anyways. So yeah, fall back to the sectional. Yep. Is this step by step in the Ultimate Private Pilot Test Prep book? I've just ordered it. It's not this whole entire detailed, but a lot of it is in there. So like you'll see like just what you're looking at now on my screen, you'll see. So it covers each kind of calculation in the Ultimate Test Prep book. Yeah, but it doesn't go in as much detail step by step as this guide does that's in our online ground school or our Checkride prep course. But yeah, it does show each and every calculation, just not as much detail. Oh, Joe, no worries. It was a good answer. What's your opinion on practicing with a VR flight simulator? So even the flight simulators that have, simulated movements like those Redbirds, even those are never, aren't quite the real thing, right? So if you're trying to practice, but I will say those Redbirds do get, and the technology is getting better and better that they can help with, practicing maneuvers and landings and stuff like that. I used my Redbirds to calculate landings and it did help a little bit, but nothing's ever going to replace the real thing. However, VR flight simulators, I think anything is useful, right? Especially if it helps you. But if you actually take it seriously and you're not just, messing around and you you get out your knee board and you actually like chair fly with your VR simulator, and you use your checklist and you go through the procedures, and maybe you do some live ATC while you're doing it, or do some ATC comms. All that procedural stuff, getting used to all that stuff can be very, very beneficial, and it can help you, when you've already done it and practiced it. That's why I'm a huge believer in chair flying, and same thing with VR flight. When you've already done it in your mind, by the time you get to the real thing, your mind is going to feel like you've already done it. You're going to have that confidence. Things are going to click a little quicker, and you're going to be ahead of the aircraft mentally, so that you can focus more on feeling, flying, looking out for aircraft, things that are ultimately most important, right? What time is this meeting supposed to end? Because everybody left. It's supposed to end, well, it says we have 62 people left. So it's supposed to end at 5, but I plan to do 10 to 15 minutes of questions. So I don't mind answering you guys' questions. Thank you very much for the presentation. Look forward to the next, but I have to go work. Yeah, gotta go work. I know. Thanks for explaining. Yeah, 64 people stayed. That's awesome. Thanks for explaining the takeoff and landing ground roll distance. No problem. Thank you for joining us. Pilot Edge is great for practice. Yes. See you on the YouTube. All right, love it. Pilot Edge. Not sure what Pilot Edge is. Pilot Edge is helping get much more confident on the radio for sure. What is Pilot Edge? The simulators helps me a lot with the procedures and flows of the plane, and also with helping at my untowered airport. Yeah. Yep, exactly. Yeah, Tracy, no problem. Chris, you're welcome. Oh, live ATC. Oh, yeah. Yeah, I've never used that. But plain English is really good. I really like plain English. I use that. Fortunately, I didn't know about it during my training, but then I used it after that, kind of to refresh for my flight review, get back up to speed working on ATC comms. And that's really cool. It like gives you like live feedback and tells you if you did it right and stuff like that. And has like a situation for like any type of VFR or IFR flight. So I really recommend plain English if you guys haven't checked that out. But if Pilot Edge does the same thing, then that's also a good tool. Oh, the plain English messes up on you, like on your phone, like it just like crashes or something. Steph, yeah, awesome, no problem. Yeah, I you know, used to do these more often, but as part-time pilot grew, I became busier and busier, so I can't always do these, but found some time, this next month that kind of cleared up with my schedule as we release our IFR course and our app, which by the way is coming out soon. Both those things. And so I figured it would be a good time to do that. Hey, by the way, anyone else, there's 54 people left. A reminder that our scholarship is our next winter scholarship, $1,000 scholarship. Deadline is January 28th. So please apply to that if you're in the online ground school. Go to your dashboard, click on My Memberships, and then you'll either see your online ground school or your bundle membership. Click on that, and then there's a link in there to the application. So Pilot Edge has paid human controllers. Cool. Help solidify what I've learned. I read that. I'm starting to, you know, I don't know. Rebecca, that sucks. I'm sorry about that. I haven't experienced that at all. I wonder, I don't know, maybe reach out to them. When do you think the IFR? Yeah, IFR. Yeah, I know. It's been a long time coming. I've got so many people have asked, when is it coming? Right now it is being peer reviewed essentially. And so a beta, I think hopefully, uh, sometime in February, we'll release a beta and it'll be, I'm thinking like half the price, with just with the kind of agreement that I'm going to be making videos. I'm still going to be making videos. There's some videos that I have yet to make to put in there. But you'll get lifetime access to that. So if you want to get in on it, for half the price, lifetime access, and then those videos will get put in there, you know, probably one a week as I make them. So yeah, hopefully February we'll release the beta. Tim, no problem. Thanks for Austin applied. Awesome. Great. Luke, no problem, man. Scott, no problem. Thank you for joining. Harry, no problem. See you next week. Thank you for joining. Eddie, no problem. Yeah, just Eddie, even if you're not at this point, just pick up what you can, ask, basic questions. There's no stupid questions, and eventually it'll start to click. Kenny would like to be in the beta. That's awesome. Yeah, well, we'll be announcing that soon, so I'll let you know. Stephanie, also, yeah, same thing. Yeah, and I appreciate you guys. We don't have an app yet, but it's coming soon. Also being tested. So like 2023 was crazy because I wrote down all these goals of things to release, like our app and our IFR and things like that. And it didn't quite happen. So I was a little bit bummed reviewing my goals of 2024, but they're really close to being done. So the start of 2024, I will be accomplishing some goals. So that'll feel good. Commercial pilot's the next step. So that's what I'll start working on next, once we get the IFR up and going good. Rich, you're welcome. Jason, February would be great. Planning, awesome. Perfect timing. No problem, Victor. Then commercial, yes. All right. All right, guys. Well, see you later. Next week, same time. I'll send out the Zoom link just like I did via email. So yeah, good luck and stay safe out there.